All right, so what I want to do in this example is show you when it is possible to have two solutions, and it does get a little long here, but I need just to explain it to you so you know how to identify, because it's not gonna, you know, I mean the problem just says if two solutions exist, and in the first problem it didn't exist, and I'm just telling you right now in this one we are gonna have two solutions, and I'm gonna point out to you what to look for in order to identify when you are going to have the two solutions. Okay? Okay, well, let's just start this as it's a regular problem right here, right? Okay, and given that the information that we have right now, you could draw a triangle right now. Okay, I'm not going to draw one quite yet. What I'm going to do is I'm just going to straight go into my law of sines. And I know, since I know capital A, small a, I know I can do sine of capital A over small a. And I know that that's going to be equal to sine of capital C over lowercase c, right? And the reason why I'm choosing those is because they gave me a and lowercase a and a lowercase c. So that's kind of how I knew I was going to use those. So let's just go ahead and plug them in right now, okay? So I know I'm going to have a sine of 60 degrees over lowercase a, which is 9, is equal to, we don't know what c is, so sine of c all over 10. Okay, so if we're going to solve now, we're going to go ahead and cross multiply. So this right here becomes 9 times sine of c is equal to 10 times sine of 60 degrees. Okay, I can go ahead and divide both sides by 9, so that sine of c equals 10 times sine of 60 degrees all over 9. Okay, so now we're trying to find the actual angle C right now. I mean, we're not interested in finding sine of C. We want to find what is C. So let's remember how we do this. In order to get rid of sine, I would need to take the arc sine, or the sine inverse of both sides. So the way that you show that mathematically is I'm going to do the sine inverse of sine of c. So I'm taking the inverse of the left side, but if I take the inverse of the left side, I must do the same thing on the right side. I must take the inverse of 10 times sine of 60 degrees all over 9. Okay, and we want that because sine inverse and sine, those are opposite operations. So this is how we get our c right here. Okay, so and this time I am going to put an approximate symbol because it's going to give us our decimal version here. So when you do that, and also I just suggest that you have your calculator out with you and you're doing this. It's so easy just to see me do it. Then when it comes time for you to do it, like on an exam, and if you're not practicing it, you're like, oh dang, like it looked easy. Of course it looks easy because I'm doing it right. So just go ahead and make sure that you're doing these calculations as well, so that you understand how to handle your calculator properly. All right, so that means you get 74. I'm going to go to the 10th place right here, 0.2. Now, check this out here. When we talked about sine inverse back in chapter 4, remember how this meant right here? This meant the sine of what is some angle, right? And which is this right here? What? 10 times sine of 60 degrees all over 9. Okay, so the inverse really means just this. Sine of what is 10 times sine of 60, blah, blah. Okay, and isn't this positive right here? Right? This is a positive number. So what I need you to think right now is this. If we're on the coordinate plane and we have our unit circle, quadrant 1 and quadrant 2, the sine value is positive. And here the sine is positive, right? It's positive in the first quadrant and it's positive in the second quadrant. So notice the degree that's been given to us, 74.2 degrees. Okay, so that's going to be somewhere like over here. Well, it could also be over here though. That's also possible. Okay, we don't know if the angle here is right here or if it's going to be on this side. Why? Because look, sine of a number in the first quadrant is this, or it could be in the second quadrant. So that's why, check this out. We can have two values for C. Okay, and the way that you find your other one, or you just subtract this from 180, or you do 180 minus 74.2. Okay, and that guy right there is going to give us 105.8. Okay, so hopefully this is making sense right now, that we get two values for C. We have this value and we have 105.8. And it goes back to the unit circle, because sine of something, when it equals a positive number, there are two ways to get sine. Okay. One more way to look at this, maybe if I take a different approach here. Okay, say if I draw a triangle now, okay, and I make one of my angles, I'm just going to go ahead and draw it right here, and I make one of my angles 74.2, and then what else was given to us? We were also given that angle A is 60 degrees, right? So that means the other one's going to be 60 degrees right here. Now watch this here, because I'm going to show you that it's possible to have two types of triangles right here. So if I add 60 and 74.2, that's going to give us 134.2. So if I subtract that from 180, then that means that this angle right here must be 45.8, right? And this actually is close. So that's given that we use 74.2 as our C. But what happens, okay, watch this now. What happens if I use 105.8 if I have an obtuse angle? So that means I'm going to make it actually wider now. So maybe like I'll make it like this, where it's now an obtuse angle now, okay? So this right now, okay, watch this now. This now becomes 105.8, right? And hopefully this is making sense here. Look at this is called an acute triangle because all the angles are less than 90. But this now we have 105.8, and then we have 60 degrees right here, right? So 105.8, if I'm going to add 60 to that, that's only 165.8. So if I subtract 180 from that, it's possible then that this angle right here can be a 14.2. So hopefully by drawing these two triangles, it shows you that, oh, C could be 74.2, and it's also possible that C can be 105.8. Okay, just by looking at these two triangles right here. If that's not really helping you out, then hopefully by using the unit circle, then that's going to kind of clarify that up, knowing that the unit circle sign is positive both in the first and the second quadrant. Okay. All right. So now that we've established that we can have, I'm going to go and erase all this now, that we can have two cases, we now need to do both cases now. Let's solve for our triangle for both cases. And that's why it takes a little while now, because you have to find all 6 things, all the 3 sides and 3 angles for one triangle, and the other 6 items for the other. Okay, so let's see if we can go through this rather quickly now. Now this is a long video, maybe one of the longest ones ever. So let's do case 1. Case 1, okay? And case 1 is when C was approximately 74.2. Okay? So, and as of right now, we also know that we know that A is 60 degrees, and we know that lowercase a is 9. And what else do we know? And I think we also know that lowercase c is, let's come up here, is 10. Okay, so when it says to use law of sines, you have to find all 6 items, all 6 angles, and all 6 sides. So we have all 3 sides and all 3 angles. So we have 3 sides So does it make sense that we have to find the other three angles? Okay. So let's go ahead and hold on here. Wait, C. Oh, this is angle C. So we have angle C, angle A, lowercase a, and lowercase c. So let's go ahead and find. Let's see. Let's go and find B then. Okay. So I'm going to do B over sine of B. That's going to be equal to, and I'm going to do lowercase a over sine of A. Okay. So don't we know what B is? Okay, because if we create a triangle, A, B, C, okay, A is 60 degrees, C is 74.2 degrees. Well, doesn't it make sense that we can find angle B very easily by just doing 180 minus 60 minus 74.2? And if you do that calculation, then that right here would give us 45.8. Okay, so now let's go ahead and plug this all in. So my side B, I don't know. So I'm going to do B over sine of 45.8 is equal to little case a, which we know. Okay, that's right here. A, and this is C. We know lowercase a is 9 over sine of A. Sine of 60 degrees. Okay, so we could actually go ahead, cross multiply and solve. So I'm going to do this all in one move right now. I'm just going to go straight to the B equals, and that means I'm going to cross multiply these guys. 9 times sine of 45.8. But that means I multiplied sine of 60 times this. That means I have to divide by it. Sine of 60 degrees. So that means if you get that approximate answer, you would get 7.45. Okay, and I think then we have everything. We have lowercase a, b, c, and we have angle a, b, c. So that means case 1 is done. Okay, now we have to do case 2. You're like, dude, you got to be kidding me, man. You got to be kidding me, dog. Nope, I'm not kidding you right now, even though I wish I was, but here we go. So now let's do case number 2 then. So let's do case 2, and that's when angle C was 105.8. Okay, and we could draw another triangle again here, so and it's kind of helpful to do that. Notice how I'm drawing an obtuse triangle now, though, right? Because our angle has to be bigger than 90 degrees, all right? And it should kind of make sense to do that. So this is 105.8. This is C, lowercase c. We'll call this capital A, lowercase a. And this is capital B, little b. Okay, let's see here. We know that angle A right here is 60 degrees. Well, that means we can find B right here, right? We can find that very, very easily by doing 180 minus 105.8 minus 60. And that gives us 14.2 degrees. Okay, so we have all three angles. We now need to find our three sides. Let's go ahead and find, I don't know, let's see, B, I guess. Let's go ahead and find lowercase b right here. All right, so let's go right here. So we're going to do B over sine of 14.2 degrees equals, and again, we want to use the precise one, so I'm going to use my 60 and my A, okay? So 9 over sine of 60 degrees. So I'm going to do it all in one big move again. So B equals 9 times sine of 14.2 degrees. And that's all over the sine of 60 degrees. So doing all that, we would get our approximate answer of 2.55. And we just found B. And we know C and A because that's what's already given to us. So that means we are done finally with this problem after 14 minutes. Oh, 15 minutes, dang.